We shall now move on to the next problem, which will be problem number 3 in this lecture on gravitation. And this one is telling that the satellite is moving in a circular orbit round the Earth with a speed equal to half the magnitude of escape speed from Earth's surface. In part A, determine the height of the satellite above the Earth's surface, and in part B, if the satellite is suddenly stopped in its orbit and allowed to fall freely to the Earth, find the speed with which it hits the ground. Radius of Earth is given to be 6400 kilometers. Free fall acceleration at Earth's surface is given to be 9.8 meter per second square, but you can't use the value of gravitational constant, that is capital G. So first of all, let us find an expression for the orbital speed of the satellite at a given height above the ground. We'll also take down the data that is given here. We have been given that radius of Earth, RE, is equal to 6.4 into 10 to the power 6 meter in SI unit. Free fall acceleration on Earth's surface, this is 9.8 meter per second square. And we also know that escape speed from the Earth's surface by formula is equal to square root of twice gravitational constant capital G into mass of the Earth ME divided by radius of the Earth RE. This formula we shall require in due course of the problem. So to get the orbital speed of satellite at the given height, unknown height, we are supposed to find out this height here only. So let me draw a figure which shows a satellite moving round the Earth in an orbit. And suppose that the radius of the Earth is taken to be RE, and the height of satellite above the Earth's surface, that is taken to be H. Therefore, the radius of the orbit small r is coming out to be Earth radius plus the height above the ground. And as the satellite is revolving in the radial direction, the force acting on it is the gravitational force exerted by the Earth on it. So since the mass of the Earth is taken to be ME, and let the mass of satellite be small m, this gravitational force Fg has got a magnitude of capital G into ME into m divided by small r square. That is the law of gravitation. Smaller distance between satellite and the Earth center, and small m is the satellite's mass. And this gravitational force is responsible for the centripetal acceleration of the satellite towards the Earth's center. This is AR. So applying Newton's second law in the radial direction, you can write down that this force of gravity Fg must be equal to satellite's mass into its radial acceleration AR. That is, putting the values now, G into ME into m divided by r square, Fg this is, equal to satellite mass into centripetal acceleration is given by orbital speed. I am using the symbol V orb for that, V orbital squared divided by the radius of the orbit. From here, from both sides, satellite mass m is cancelling out, 1 r cancels out, and therefore we are getting orbital speed squared is equal to G into ME by small r, and eventually you might write orbital speed is coming out to be square root of G into ME by small r. That is my next important result. Here G is gravitational constant, ME is the mass of the Earth, but small r is standing for the distance between the Earth center and the satellite. That is radius of Earth plus the height above the ground, right? So, according to the question, this orbital speed is half the escape speed from the Earth's surface. Therefore, using the given condition, we might write down that since V orbital is equal to half the escape speed from the Earth's surface, we are getting from here square root of G into ME by small r, this is equal to half into square root of 2 into GME by RE. Squaring both sides, we could write down G into ME by small r is equal to half whole square, that is 1 upon 4 into 2 into GME by RE. This 2 and 4 giving me half in the right hand side, also GME cancelling out on both sides, and we are getting that the distance of the satellite from the Earth center smaller is equal to twice RE. That since smaller is equal to RE, the Earth radius plus the height above the ground of satellite, it follows therefore that satellite's height above the Earth's surface is simply equal to the radius of Earth, that is given to be 6.4 into 10 to the power 6 meter. So this is the first part of the answer. We conclude that satellite is revolving around the Earth at a height equal to Earth's radius.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.